Okay. So another question is modeling and finite element analysis of a simply supported beam having a rectangular cross section with a uniformly distributed load such as Q equal load per unit length as shown in figure. So this is the given diagram. Here we can see the support here where support reacts on RE and RB and the applied force Q which is uniformly distributed along this beam. Now let's assume the dimension of this beam. Suppose length of the beam is 200 meter and the loaded force is around 500 Newton per meter and the size is 10 into 10 meter. So let's move to the workbench. For this we have static structure. Now right click on the geometry and then new design model geometry. Here select XY plane. Now go to the sketch, select rectangle, draw a rectangle here, give it dimension 10 into 10. So first we have horizontal dimension, sorry, it's horizontal h1 and then vertical 10 into 10, 10 is one also 10. Now go to the model, select XY plane and sketch 1, extrude it, then generate it. Select sketch 1, extrude it, apply, depth is around 200 since our length of the beam is 200, so it's 200 meter, 200. 200. Okay, generate it. Okay, we have this beam. Now let's move to model, double click on model, it takes few seconds. After launching we go for a meshing part. So here it launched successfully. Now click on the mesh, right click, then we have to sizing. For meshing we have to size first, so click on the right side mesh and right click, then sizing, then select the body, select the body, then click on apply, and then element size around 5 m. Click on mesh, right click, then generate mesh. Now we have successfully calculated the meshing. After that, go for static structural, right click on static structural, insert. Then we have to fix both side. First we have to fix this support, so we click fix support, then select the edge, select this bottom edge, then click on apply. Now for another support, same process, click on the right right click, then here click displacement, then select this x-axis edge, then click on apply. Here x and y is constant, so no movement in xy, so it becomes 0 0, and z-axis is free. So here this is x is constant, and also for y it's also constant, and z component is free. Now click on the solution, right click, then insert deformation directional, then click on the right click, then stress equivalent, then also right click in the equivalent, insert convergence. Here allowable sense around 1%, so it sends around 1%. Now click on the solution, max refinement loops uh, around 3. Now click light, and then click on the solve. Something went wrong. Oh, force is not given. Structural, static structural, right click, then will give force. Force is apply on the face, which is uniformly distributed. Click this side, then apply, and the magnitude of force around 500 Newton. Then direction, uh, downwards direction in y-axis. Click on apply, then so it should be run now. Yes, process is ongoing. It took few seconds. So this is the process. You can find finite element of this supported beam, and the force is uniformly distributed. So here directional deformation you can see. This is directional deformation. Here the max and mean load is deformation is applied because force is uniformly distributed around this beam. Here also equivalent stress, you can see the blue line, this is axial line. Max min here also be marked properly. So this is the solution of the given question. You can see the deformation and directional deformation also. Thank you.